Hello viewers, welcome back. We are discussing matrices, basic definition of the matrix, order of the matrix, multiplication of the matrix, addition of the matrix, etc. We have discussed, and let us go forward in this topic with transpose of a matrix. Transpose of a matrix. Transpose. What do you mean by transpose? When you take a matrix and if you interchange the rows and columns of that matrix, interchange the rows and columns means rows must be turned as columns and columns must be converted as rows. That is interchanging rows and columns. In place of rows, columns will come. In place of columns, those rows will be replaced. That is called transpose of a matrix. Suppose A is equal to 1, 2, 3, 4, 5, 6. I am writing 2 rows and 3 columns. Order of the matrix is 2 by 3. Now, if I write another matrix by taking these rows as columns of that matrix, I'll write this first row as a first column of the matrix. This is second row as second column of the matrix. That matrix is called transpose of A, that which is denoted as A transpose. Sometimes A dash also will write. A dash or A transpose. If you interchange the rows and columns, here you see first row 1, 2, 3, here first column is 1, 2, 3. Here if you see first column is 1, 4, here first row is 1, 4. Here column is converted into row and the row is converted into column. That type of matrix is called transpose of the given matrix. If you observe the orders, here 2 rows are there, 3 columns are there. Here 3 rows are there, first row, second row, third row. 3 rows and 2 columns. Exactly the previous order is reversed. Columns are 3 here, here rows are 3. Here rows are 2, here columns are 2. This is called transpose of the matrix. So, whenever a matrix is given, Aij matrix is given, if you interchange M by N matrix, if you interchange I and J numbers, rows into column, column into rows, Aj of matrix N by M will give you transpose of the matrix. Will give you transpose of the matrix. So, whenever you interchange the rows and columns, you will get the transpose of that matrix. If note, if A transpose is equal to A means the matrix appears the same even if you interchange the rows and columns. There will not appear any change in the matrix. The type of matrix is called symmetric matrix. Symmetric matrix. The type of matrix is called symmetric matrix. Even if you interchange the rows and columns, matrix appears the same. It will not be changed. For example, if I write A is equal to A, B, C, B, C, A, C, A, B. If this is the matrix, if you interchange the rows and columns also, if you want to write the first row as first column is also same. So, here if you transpose this matrix, again you will get the same matrix. The type of matrix is called symmetric matrix. The type of matrix is called symmetric matrix. Another type is there, skew symmetric matrix. Next is skew symmetric matrix. What is skew symmetric matrix? Skew symmetric matrix. Skew symmetric matrix means when you take the transpose of the matrix, if it is equal to A, that is called symmetric. If it is equal to minus A, that is called skew symmetric matrix. Skew symmetric matrix. Skew symmetric matrix. So if A is equal to Aij of order m by n, skew symmetric matrix will be minus A dash element, which is minus Aj of order n by m, of order m by n, n by m. A transpose is equal to minus A, or A is equal to minus A transpose, both are same. That is called a skew symmetric matrix. For example, if I write A is equal to 0, minus 1, 1, 0. If you take the transpose of this matrix, first row I should write it as first column, second row I should write it as second column. If I multiply with minus, here you will get minus, here you will get plus. Again it will be equal to A. Here again it will be equal to A. A transpose is equal to minus A, or A equal to minus A transpose. Hence this is a skew symmetric. This matrix is called a skew symmetric matrix. Observe that skew symmetric matrix always diagonal elements will be same, because for diagonal elements I will be equal to j, a11, a22, a33, it will be like that. So here if I equate aij equal to minus aji element, if you put I equal to j here, this implies aii is equal to minus aii. This implies 2 into aii equal to 0. This implies aii is equal to 0. Diagonal elements, ii means a11, a22, a33, a like that. Every diagonal, principal diagonal element will be 0 in case of skew symmetric matrix. Okay, 3 by 3 skew symmetric matrix will be there. For example, 0, 1, minus 2, minus 1, minus 1, 2, 0, minus 4, 4, 0. If I take this matrix, if you take the transpose of this, here minus A transpose will be equal to A. If you take the transpose and if you multiply 0, 1, minus 2, right in the column, if you multiply with the minus, you will get this. So, if you take the transpose and if you multiply that with minus, again you will get the same matrix. These type of matrix are called skew symmetric matrices. So symmetric means A transpose is equal to A. Skew symmetric means A transpose is equal to minus A. In skew symmetric, observe that principal diagonal elements will be zeros. Transpose means interchanging the rows and columns. So let us quickly check what are the laws of transpose. Transpose will satisfy what types of laws. Very first one is, if you take the transpose 2 times, you will get the same matrix. A transpose whole transpose is equal to A. That is very basic law. Second one, if A and B are any two matrices, A plus B whole transpose, A plus or minus B whole transpose is equal to A transpose plus or minus B transpose. Individual transpose sum will become transpose of the sum. Next, product AB whole transpose is equal to B transpose into A transpose. Second matrix transpose into first matrix transpose, you will get AB whole transpose. Fourth one, K is any scalar, K into A whole transpose is equal to K into A transpose. Real number does not play any role in that, so you can keep the real number out. You have to take the transpose of the matrix. These are the basic laws of the transpose. And one more small corollary is there. If A is any symmetric matrix, if A is any symmetric matrix, if A is any symmetric matrix, if A is any, if A is any square matrix, if A is any square matrix, A plus A transpose is always symmetric. A plus A transpose will give you always a symmetric matrix. A minus A transpose will always give you skew symmetric matrix. Will always give you skew symmetric matrix. These are the main things related to transpose. A transpose, whole transpose is equal to A. If you take the transpose two times, you will get the same matrix. Transpose of the sum is equal to sum of individual transposes. Transpose of the product equal to second matrix transpose into first matrix transpose. If you take the transpose of a matrix multiplied by a scalar, you can keep the scalar outside and it into transpose of the matrix. Whenever if you take an A is any square matrix, you can verify this by taking any example. A plus A transpose, always result will be symmetric again. A minus A transpose result matrix is always skew symmetric. Based on this, we will do one or two problems based on transpose. Let us do this problem. A is equal to 2, 0, 1, minus 1, 1, 5. B is equal to minus 1, 1, 0, 0, 1, minus 2. Find AB transpose, whole transpose. I will use the law here, transpose laws I will use. X into Y whole transpose is equal to Y transpose into X transpose. This is the basic product transpose law. Second matrix transpose into first matrix transpose. Here second matrix is B transpose. So second matrix transpose means B transpose, whole transpose I have to take. In place of Y, B transpose is there. In place of X, A is there. One problem here, A matrix is given, B matrix is given. Find AB transpose, whole transpose. I will use the transpose law here. X into Y transpose is equal to Y transpose into X transpose. Second matrix transpose into first matrix transpose. Here second matrix is B transpose. So B transpose, whole transpose into first matrix is A, that is A transpose. Already I told 2 times transpose if you take, you will get the same matrix. So B transpose, whole transpose is nothing but B into A transpose. What is B matrix given? Minus 1, 1, 0, 0, 1, minus 2 into A transpose. You have to change the first row as first column. So 2, 0, 1 I am taking the first column. Second row as second column, minus 1, 1, 5. I am taking the second row as second column. Multiplication property I am checking. First matrix is having 2 rows, 3 columns. Second matrix is having 3 rows, 2 columns. So, number of columns in the first matrix is matched with number of rows in the second matrix. So, I can multiply. So, I can multiply the matrices. What is the resultant? Here take the first row. Here take the first column. Multiply. Minus 1 into 2, minus 2. 1 into 0, 0. 0 into 1, that is 0. Next, first row into second column. Minus 1 into minus 1, 1. 1 into 1, 1. And 0 into 1, minus 1 into minus 1, 1. 1 into 1 is 1. 0 into 5, that is 0. Second row multiplication. Next, second row multiplication. Take this second row into first column. 0 into 2, 0. 1 into 0, 0. Minus 2 into 1, minus 2. Second row into second column. 0 into minus 1, that is 0, 1 into 1, that is 1, and minus 2 into 5, that is minus 10. This is the resultant matrix. This is the resultant matrix. So the answer is minus 2, 2, minus 2, minus 9. This is the result of AB transpose, old transpose. First row into first column here, first row into second matrix, second column. Again you see minus 2, 0, 0. Next plus 1, 1, 0. Second row into first column, 0, 0, minus 2. Second row into second column, 0, 1, minus 10. So this is the resultant of the matrix, required matrix AB transpose or transpose. Thank you. I'll explain the remaining things and previous JEE problems in the next video. Thank you.